Hello, it's Dr. Bhatt here. Today we will take up a topic which is known as dehydration of alcohol. So we shall get into what are the products of dehydration of alcohol and certain mechanisms considering primary alcohol as well as the secondary alcohol, also the tertiary alcohol. Now, before we get into anything, we need to understand what is meant by dehydration. Dehydration simply means removal of water from a molecule. Now, in this case, it is alcohol. Considering ethyl alcohol or ethanol to be the case, a primary alcohol, this ethyl alcohol can also be written as C2H4.HOH. Now, if you remove HOH, that is water, what will be left over? It will be C2H4. Therefore, one of the products of dehydration of alcohol is alkene. Besides that, under different conditions, using a suitable catalytic dehydrating agent, we can get ether and also alkyl hydrogen sulfate. Now let us view how they are obtained. Here it is dehydration of primary alcohol in presence of concentrated sulfuric acid. Concentrated sulfuric acid is a dehydrating agent, and at a temperature of 110 degrees Celsius, on heating with concentrated sulfuric acid, you get ethyl hydrogen sulfate. Of course, water is given out. But when excess of concentrated sulfuric acid is taken and the temperature is maintained at 240 degrees Celsius, the reaction takes place in two steps. And here, the final product is C2H4, as you can find it out here. Then, here, when excess alcohol is taken, sulfuric acid is in lesser quantity, alcohol is in more quantity. Then you, at a temperature of 170 degrees Celsius, you get an ether, ROR, RC2H5, OC2H5. Besides this, if alcohol is heated with fuming sulfuric acid, you get an ester, which is known as diethyl sulfate. Here is the structure. Okay, now we need to understand how to remove a molecule of water from a molecule of alcohol. Undoubtedly, it is different. Removal of water molecule is different that of evaporation or vaporization, etc., which has been only a physical process. Now here we have to remove a molecule of water from a molecule of a particular compound. In this case, it is alcohol. So we have to use something which will extract or take up water. And that substance would be a dehydrating agent. Of course, it much depends upon the nature of the alcohol. Alcohol itself is amphoteric in nature. By amphoteric, we mean it can behave as an acid as well as a base. An equilibrium is established here. Alcohol, as you find here, it can be represented and type formula as ROH. The oxygen atom here contains two lone pair of electrons. The presence of lone pair of electron in oxygen atom of the hydroxyl group makes it weakly basic. It is this basic character that the use of suitable acid, we can, particularly a strong acid, we can cause protonation. And dehydration takes place because of the presence of a strong sulfuric acid. Here is an equilibrium shown here, formation of alkyloxonium ion and alkoxide ion. When it behaves as a base, we get alkoxide ion, and when it behaves as an acid, we get an alkyl oxonium ion. The dehydration of alcohol needs an acidic catalyst to convert hydroxyl group into a good leaving group. This is an equilibrium reaction as you find here, and the addition of a dehydrating agent such as concentrated sulfuric acid causes alcohol dehydration via E1 mechanism. But uh, we need to know that there can be another dehydrating agent which is better than sulfuric acid, concentrated sulfuric acid. Why? Because the sulfuric acid, when used, gives massive results. Massive results means it gives products uh, uh, along with the main product, you get many other products as impurities because sulfuric acid itself acts as an oxidizing agent and therefore it gets reduced to form sulfur dioxide. It may alcohol, a part of the alcohol or certain amount of alcohol may be oxidized to form carbon dioxide. And not only this, as a result of the heating of sulfuric acid to a particular temperature, carbon may also be present. So a number of byproducts or side products are formed which are undesirable and must be removed to get pure alkene. So there is another dehydrating agent and that is phosphoric acid. Phosphoric acid is a better dehydrating agent as compared to sulfuric acid, concentrated sulfuric acid. Now let us see what happens actually when the dehydration occurs. That is mechanism of dehydration of alcohol into alkene. Dehydration of alcohol forms alkene. The OH group in the alcohol donates 2 electrons to hydrogen from the acid reagent forming an alkoxone. That is what we have already discussed earlier. This ion acts as a good leaving agent to form a carbocation. The deprotonation protonated acid acts as a nucleophile and attacks the hydrogen adjacent to the carbocation and forms a double bond. Primary alcohol, of course, very important, undergo bimolecular elimination reaction E2 mechanism, and secondary and tertiary alcohol undergoes unimolecular elimination reaction E1 elimination. So, if you have to categorize or rank the relative reactivity of alcohol, methanol is least and tertiary is most. Tertiary reacts faster and therefore the order of reactivity is as shown here, methanol lesser than primary, then lesser than secondary and then tertiary. So that means primary alcohol is not readily dehydrated, tertiary alcohol is readily dehydrated, means it can be dehydrated at a lower temperature also. So now here are the steps of mechanism. Alcohol, oxygen atom in the ethanol consists of 2 lone pair of electrons as we have seen, and sulfuric acid is provides a proton. So this proton immediately reacts with the lone pair and forms a hydronium ion which is attached over here. So this is a intermediate product and this takes up, because it is positively charged, it attacks or takes up the hydrogen atom adjacent to it, to the alcoholic group, and you get a carbocation. And the carbocation here is generated, and because of the carbocation, here there is a slow and rate determining step. Of course, protonation is a faster step. It is exothermic in nature, where this is a slower step. And carbocation gets stabilized, yielding an alkene as the final product. Okay, we stop here and we shall be back again with certain other details after some time. Okay, thank you.